Today we're going to be working on an FRQ, and this is from the 2016 free response questions. This is question number 4. So this question was a question you could not use a calculator on. So this is a pretty typical differential equation. There's usually 2 or 3 parts. The first part gives you a slope field to solve, and there's 6 points that we're going to find the slopes for. And remember that a derivative also means a slope. So here is our slope formula right here. Y squared over x minus 1. So I'm going to actually make a list of the 6 points so I can keep track of my slopes. So I have a point at 0, 0, 0, 1, 0, 2, and I have points at 2, 0, 2, 1, and 2, 2. So I'm going to find the slopes at each of those points. So if I plug x and y into my formula up here, I get 0 over 0 minus 1. So that gives me 0. So on 0, 0, I'm going to plot, or I'm going to draw in a slope that represents a 0 slope. At 0, 1, I get 1 squared, which is 1, over 0 minus 1. So 1 over negative 1, which is negative 1. So at 0, 1, I have a slope of negative 1, which is a perfectly diagonal line. At 0, 2, my slope would be 2 squared, which is 4, over 0 minus 1. So 4 over negative 1 gives me negative 4. So at that point, I'm going to draw a pretty steep line. Now, in the AP exam, they're not going to be too picky. As long as it's a steeper line than the one before it and it's a negative slope, then you'll get full credit. So at 2, 0, my slope would be 0 over 2 minus 1, which would give me 0. And at 2, 1, my slope would be 1 over 2 minus 1, so 1 over 1, which is 1. And then at 2, 2, we have 4 over 2 minus 1, which is 4. So I've got my 6 points there. And on the AP exam, how they graded this part A is you got 2 points. 1 point was given for the correct 0 slope, so these 2 points got you 1 point. And then all the other 4 points got you another point, so 2 points total. Okay, so let's move on to part B. Part B says, let y equals f of x be the particular solution to the given differential equation with the initial condition of f of 2 equals 3. So right there, I think I have a point. Write an equation for the line tangent to the graph of y equals f of x at x equals 2. Use your equation to approximate f of 2.1. So I've got a 2-part question here. First, we're going to write an equation for a tangent line. So the point that we're given is 2, 3. Now to write an equation of a tangent line, I need the slope. So I'm going to use my slope formula from up above, my derivative up here, to find my slope at that point. So slope would be 3 squared over 2 minus 1, 9 over 1. My slope is 9. So now I can write my equation of a tangent line using my point slope formula. Y minus y1 equals m, x minus x1. So that's the first part of the problem. The second set of directions says, use your equation to approximate f of 2.1. So I'm going to do exactly that. I'm going to use that equation, y minus 3 equals 9, and instead of x, I'm going to plug in 2.1. 2.1 minus 2 is 0.1. 9 times 0.1 is 0.9. If I add 3 to both sides, y is approximately 3.9. So how they graded this part B is you got 2 points for this. 1 point was writing your equation of your tangent line, and the other point was getting your correct approximation. So we're up to 4 points here. That leaves 5 points for part C. Part C says we're going to find the particular solution, y equals f of x, to the given differential equation with the initial condition f of 2 equals 3. So right away, I notice it says find y equals f of x, which means that we're going to solve for y. So I'm going to go down here. I'm going to rewrite my differential equation, dy dx equals x squared over x minus 1. And we're going to solve this for y. So first thing I always do is separate the variables. So I'm going to first cross multiply, it just makes it easier. That gives me x minus 1 dy equals y squared dx. So both of these actually we have to divide to the other side to get the variables on the correct side. So on the left side I'm going to have 1 over y squared dy, and on the right side 1 over x minus 1 dx. Okay, so next step I'm going to take the integral of both sides. And on the left side, I'm actually going to rewrite this, y to the negative second dy. The right side here, I have an integral of 1 over x minus 1. The problem with this is that I can't just rewrite it because it has an inside part to it when I rewrite it. If I tried to do x minus 1 to the negative first, I would still have an inside part. So what I'm going to do is leave it like this, but I'm going to do a u substitution, and I'm going to set u equal to the bottom. Du, fortunately for us, is just 1 dx, so I don't have to add anything into the problem. I'm just going to write this as the integral of 1 over u du. So now I'm ready to take my integral. On the left side, I'm going to add and divide, so that's negative 1 is my new exponent, so negative y to the negative first. On the right side, we have the ln of u plus c. And I'm going to plug back in for u. And I'm going to solve for y first here. So first thing I see is I have a negative exponent. So I'm just going to rewrite that 1 over y. I'm going to bring this up to the top here so I have a little more space to work. I'm going to divide both sides by the negative. So 1 over y equals negative ln of x minus 1. And the plus c still stays a plus c. And a quick fix to move the y to the numerator is to put y equals and then put the right side in the denominator. Okay, so last step, they give us an initial condition. They give us a point of 2, 3, and that comes from our problem right here, f of 2 equals 3. So I'm going to plug these points in, and hopefully that'll let me solve for c. So I'm going to plug 3 in for y, and 2 in for x, two minus 1 is 1. The ln of 1 is 0. Hopefully we remember that. So we have 3 equals 1 over negative 0 plus c, so that's just c. So that means c would have to equal 1/3. So my final answer, I have to now write my y equals, right? The directions say find the particular solution, y equals. So I'm going to go and write my particular solution. Y equals 1 over negative ln of x minus 1. And my plus c I just solved for, so plus 1/3. So there's my final answer. So let's just take a look at the scoring guidelines for this question so you can see how you would have gotten your full credit. So I'm going to switch over to the scoring guidelines. So I already went over part A, right? Part A, here's an example of what your slope field should look like. You get 1 point for the zero slopes, 1 point for the non-zero slopes. Part B, I went over as well. You get 1 point for your tangent line approximation. Now they moved the 3 over to the other side. You don't have to do that. Remember, in calculus, you don't have to simplify. And then 1 point for your approximation. So C, there's 5 points. So let me go over how they grade this. 1 point is for the separation of variables. So when you move the y's over to one side and the x's over to the other, you get a point for that. 2 points for taking the integral and having those correct. So if you miss one side, you would only miss 1 point there. 1 point if you remember to put your plus C and plug in your initial condition. And then 1 point for correctly solving for y. Now at any point, if you make a little mistake in there, but all of the rest of your work is correct according to your mistake, you would get credit for everything except for that initial mistake that you made. So some of these though, you'll see there's a max points. So if you never separated your variables at all, that means you didn't start the problem correct in any way. You don't get any points. You want to make sure your first step, you work really hard to get that correct, or at least move your x's to one side and your y's to the other. Even if you make a little mistake while doing it, you'll get credit for it. But if you don't do that step at all, you won't get any points. They also would, if you forgot your C, you'll definitely miss 2 points because there's no way you could have correctly solved for y or plugged in your initial condition without at least having a C to solve for. Okay, so that concludes this FRQ. Feel free to rewind or repeat anything or email me if you have any questions.